7.3, graphing with the table of values. Who remembers what I called the table of values when we did these on Friday? I'd go like this, and I'd call my table of values by using a
T-chart.
A T-chart. Good memory. All right, so I'd like you to get down the definitions, please. First one is a solution of a linear equation. That is when an ordered pair, meaning your x and your y, that when substituted into the equation will make the equation true. Makes it work. And then function notation. When writing an equation, you use f of x in place of y. And how do we say this? Right here, I would just set it out loud. It is read as f of x, or the function of x with input y. So for the example, instead of y equals 2x plus 1, we can put f of x equals 2x plus 1. All right, like I was mentioning, tomorrow's the quiz, and the quiz question bonus will be, how can you tell by just looking at an equation if it's going to make a line or not? Right now, you look at this equation, you're not sure. Will that make a line or not? I can tell by it, looking at it, but I'm not going to give it away. I want to see if you can pick it up by today's assignment, and then hopefully you'll get the bonus tomorrow. Example number 1. Graph each function using a table of values. Your table should have at least 3 points indicated in the function to indicate the function is linear or nonlinear. Now this says 3. My rule is 4. And notice on this example, they give you the 4 numbers to use, don't they? When you start your homework today, pages 7, 8, 9, and 10, which sounds like a lot of homework, 4 pages, but it's only 8 problems. Because look at how much room it takes just to write 1 problem. Okay, so you only have 8 of these to do for your homework. But when you look at your homework, the 4 numbers are not given to you. I give you these 4 numbers, so we're all going to be using the same ones on this problem. However, say this was your homework. Courtney, you might have used 3, -2, 1, or 0, and -3. You could have used those numbers, and we would have still gotten the exact same line or plot on the graph. Our points would have been in different spots, but it would have made the same line, okay? Another hint. These aren't as good because they're not bad, but another hint, when you make up your 4 numbers, these are really good ones to use because they're close to the what? They're close to the origin. I mean, I could use 10, but then, or 20, but if I go up here, what's 10 minus 4? 6. So I'm going to go 10 and 6. If I use 20, it's going to be off my graph. So it's always best to use your smaller numbers. All right, let's practice with the 4 that I have. So the first thing we do, here's the equation that they want us to graph. I like to write that and have you write that on top of your graph. Y equals x minus 4, because that's going to indicate what my line is, or nonlinear. So see this x right here? That's what we're going to substitute in. I can pick any numbers. I picked a -2, comma. If I put a -2 in for the x, what's -2 minus 4? -2 minus 4, right? Battle of the integers, there's no fight, so it is a -6. So let's plot that. -2, -6. Right there. Just by 1 point, I can't tell if it's linear or nonlinear, can I? Nope, that's all we need to do more. Well, what if I do 1? What's -1 minus 4?
-5.
-5. So -1, -5. Plot that. Can I tell still if that's going to be linear or not? Can I tell if those 2 points are going to make a linear or a nonlinear equation? With 2 points?
Yes.
What if the next one's way over here? Or maybe up here? That's why they say 3 for sure. I say 4. My rule's 4. So let's do the 0. y equals, and by the way, you should always put your x in parentheses, and you'll know why when it comes to being a negative every once in a while, so it doesn't get you mixed up and you don't get any wrong. So my x is now a 0. So what is 0 minus 4? Negative 4. Let's plot that. 0, negative 4. Now it's looking good. But what if you would have went 0, negative 4, and you would have plotted it over here? You would have thought, oh, this is going to be a nonlinear, isn't it? If you would have goofed on your plotting. Instead of putting it here where we're supposed to. That's why I like this fourth one. Now I go 1. What if I put a 1 in here? What's 1 minus 4? Negative 3. Let's go 1, negative 3. And then, so if you've got these two and this one over here, what are you going to do? Reevaluate and look. Did I do this one right? Oh, no, that doesn't go there. That goes here. Okay, so that is what? Linear or nonlinear? That is a linear equation. It is linear. Are these, now that's kind of like what I was talking about when I said you can pick your own points. Are these the only 4 solutions to that equation? No, not even close. No, it is not. Give me an example of some other ones that would be on that linear equation on that line if we were to extend it. 2. What do you want?
2, negative 2.
2, negative 2. Perfect. So put that on the line. 2, negative 2. Does that work in our equation? Yeah. What is 2 minus 4? A negative 2. It did work. I could go here and know that it's probably going to be here. What's this one?
3, negative 1.
3, negative 1. I could just keep going. I could have all kinds of different solutions on that line, on that equation. It says, how many solutions are there? Think Toy Story.
Infinity and beyond.
Infinity and beyond. It keeps going. This line keeps going and going. It's not a line segment. It's a line. It has the arrows. It goes on. How many solutions? It is infinite. Sometimes you might see, it might refer to it as all solutions. But infinite is what we're going with. It's infinite. All right. Here. How do we say this? We don't say f times the parenthesis x. We say f of x. So for our f of x equals a negative 5x. And I give you two numbers. Well, I gave you a negative 2 and I gave you a negative 1. You certainly can use a calculator if you're not sure, if you're not confident in yourself with the integers yet. So let's see. What does the f of x equal if we put a negative 2 in here for our x? What's a negative 5? What do I do here?
Negative 5 times negative 2.
Right. I'm going to multiply. What's a negative 5 times a negative 2?
10.
Negative or positive? Positive, all right. Now let's put a negative 1 in here. What's negative 5 times a negative 1? Positive 5. What other numbers do you want to use? 25? No, that's too far from the origin. Give me another two numbers. Blurt couple. My favorite, yes, 0. And positive 1. Perfect. All right, so what do I get if it's 0? What's negative 5 times 0? 0. How about if I put a 1 in here? What's a negative 5 times a positive 1? Negative 5. Okay, so let's plot these and see if it's linear or nonlinear. Negative 2 and 10 is way up here. Negative 1 and 5. 0, 0. And 1, negative 5. Is this linear or nonlinear? Linear? Does it make a line?
Yes.
It is linear. Makes a straight line. explaining it would be what? Because it makes a straight line. And we're gonna be able to add to that explanation at the end of the class period tomorrow after the bonus, and you can see if you figure out how you can tell by just looking at an equation if it's going to be linear or nonlinear. I don't want to give that away now. Oh, this is such an easy one. Y equals X. Give me any numbers. 1, 3, 4, -2. Huh? All right? They're pretty simple. If Y equals X, well, if X is 1, what does Y equal? 1. They're equal to each other. So what's this one equal?
3, 4,
Nice. Plot them. Is it linear or not? Linear or nonlinear?
Linear.
Totally linear. Why? Yes, it does. It makes a straight line. And whenever it's y equals x, it goes through your origin as well. 0 equals 0. All right, now let's do this one. Y equals x squared. Give me 4 numbers. 1.
8.
0, my favorite.
-1.
Ooh, good one. And
-2.
-2. I like it. Let's figure this out now. Y equals x squared. Put parentheses around your x, your variable. Now let's take our x. We're saying our x is a 1. What is 1 squared?
1.
Still equals a 1. What's 0 squared? Still a 0. What's -1 squared?
1.
-1 times the -1 is?
1.
Positive 1. What's -2 squared?
-4.
A negative times a negative is a?
Positive.
So it's a positive
4.
4. Linear or nonlinear? Let's graph them and find out. Linear or nonlinear? That one is totally nonlinear. Why?
Not a straight line.
Doesn't make a straight line. Excuse me. Okay, this is the last one we're going to do on our notes for today, because I want to introduce you to one that has a fraction. Now, you all know how to turn them into a decimal. However, there's certain numbers when it comes to graphing, and I'm letting you pick your own numbers. Whenever you see a fraction, the numbers you're going to want to use to make your life easier is always 0. And then, what is our denominator in our fraction? 2. And then you want to use its negative. And then double the denominator. What do you get? 4. Take it times 2. The reason for that, because then we'll end up with whole numbers. That way you don't have to go half of 5 plus 1. Because what's half of 5? 2.5 plus 1, 3.5. So you don't have to go over here and go 1, 2, 3, 3.5, and then, go by halvesies or eighths or whatever it might be. This way you always work with whole numbers. So what if you had the fraction 1/3? What would be the best 4 numbers to use?
0, 3, -3, 6.
Excellent. How about if I had 1/4?
0, 4, -4.
Excellent, so you guys get it. All right, let's look at our original problem. Now, 1/2 of 0, 1/2 times 0 is, and even if you're not sure, put it in on your calculator now. You can still turn this into a decimal, 0.5. 0.5 times 0, well, anything times 0 is what? 0. What's 0 plus 1 now? 1. What if I put a 2 in here? What's 1/2 times 2 over 1 plus 1? 1/2 times 2 is 1 over 1, which equals 1. What's 1 plus 1? 2. Now let's do this with a negative 2. 1/2 times a negative 2 over 1 plus 1. What do I get? What's 1/2 times a negative 2 over 1? I'll write it bigger. 1/2 times a negative 2 over 1. Negative 2, to make it a fraction, you put it over 1. 2 goes into here once, 2 goes into here and negative once. What do I get? What's half of a negative 2?
1.
Close. A negative 1. So now we're not done though. We have to plus 1 to it now. So what's negative 1 plus 1? 0. How about 4? What's half of 4? 2 plus 1? 3. Okay, let's graph that. Does it make a line? Yes or no?
Yes.
It should. I can tell by looking at the equation that it should make a line. If yours didn't make a line, you did something wrong. That one is linear for sure. Why? Well, the reason you know why is because it makes a straight line. And after the quiz is bonus tomorrow, you'll know another reason to know why it should make a line. I'm going to see who can raise your hand if you think you know the answer to that bonus tomorrow on the difference on when it was linear and when it was not linear. Anybody? Oh, exciting. Tomorrow it will be unveiled. Your assignment, that's all we're doing in the notes. I want you to do pages 7, 8, 9, and 10. It's 4 pages, but like I said, it's only 8 problems because they take up so much room.